Okay, on problem 4, we have a population mean equal to 70 and a standard deviation of 20. And it tells us we have an interval that goes from 30 to 110. And so that would be the mean plus or minus 2 standard deviations, or 70 plus or minus 2 times 20. And that interval is equivalent. Always the mean is going to be in between, so you could just, if you want it, well, you know the mean is 70, and just put that in between there and look at how many standard deviations. Of course, 70 to 30 is a distance of 40, and that's 2 standard deviations, and so on. This is not, it doesn't tell you that you have a normal population. So when you don't have a normal population, use Chebyshev's rule, which is if you take the number of standard deviations, you will have 1 minus 1 over k squared percentage of the data, or proportion of the data in that interval. So 1 minus 1 over 2 squared, that's the 2 right here, will give you 0.75. So you have 75% of the data, and that is then option B would be the answer on that one. Okay, so on the next problem, number 5, we have a normal population, and we're given a population mean of 300 and a population standard deviation of 30, and it says we want to find the proportion of values below 240, so we're looking for that. And this distance, 30 to 240, you could just take the distance 240 to 360, divide by 2. It's really minus 2. It just means you are 2 standard deviations below the mean. Well, remember from the empirical rule, if you go the mean plus or minus 1 standard deviation, this is in a normal population, you will have 0.68 of the data. The mean plus or minus 2, you'll have 0.95. And the mean plus or minus 3 standard deviations is 0.997. Well, this is 2 standard deviations. Well, that's 9.5 would be if we went in both directions, but we've only gone in one. So the area right here from that I have arrowed here is 0.475, and that's just 0.95 divided by 2. But that's not the area we're looking for. We're looking for the area out here. So to get that, we know that this is a perfectly symmetric distribution with half of the data, or 0.5, below the mean of 300. Well, if it's 0.5 from the mean down and 475 here, the area in the tail is going to be 0.5 minus 0.475 over, that's 0.025 will be the answer on that. And that is option D. So on the next one, we still have that population mean of 300 and standard deviation of 30. And it's asking for the 16th percentile. That means that 0.16 of the data are below this point. So we're actually looking for a value of x now. Remember, everything has to be from the mean to some point. Well, if we have 0.16 below here, this has got to be 0.34 because we know from the mean down is 0.5. So if we just take the 0.5 minus the 0.34, we have 0.16. That means that this x is the mean. It's 1 standard deviation below the mean. So it's going to be the mean 1 minus 1 times 70, or 3 or times 30. So minus 30, and that's equal to 270. And that is B. Okay, so we'll move down a little further here. And this one, actually, I'm going to move this out of the way, widen this out a little bit. And in this one, we have, I think I got everything there. Okay, here we go. I know I skipped one. So on number 7, microphone keeps pulling away from me there, so hopefully that's a little clearer. On number 7, we have the average salaries in 3 sports, and then so we have them in 1993 and 2003. And we're not making an inference about anything else, just there they are, those are the things. So it's going to be descriptive statistics. If we were making an estimate of something else, it would be inferential statistics, but we're just describing the salaries that we have in the 3 sports in those 2 years. So that will be C. So for number 8, each month, interviewers visit 55,000 of 76 million households and ask the occupants over 14 questions about their employment status. So we're looking at the percentage of people in the labor force who are unemployed. The population is not the 76 million households, because we're actually looking at people, and some households are going to have more than one occupant over 15. So it's all the people in the region that are over 15 years old. And then what is statistics? It is the science that deals with the collection, classification, analysis, and interpretation. This first thing here is an estimate or prediction of some other generalization. That would be a branch of statistics, inferential statistics, but it's not the whole field. A characteristic or property of an individual experimental unit, that would be a variable. And a process used to assign numbers to variables of individual units, that's just measurement. Okay, on number 10, I kind of wish I had done a little bit different with this question, or added something to it. It says we've got the 30 export markets for sparkling wines, and we have a descriptive statistics printout for the amount exported. The variance is, I wish I would have made it, it's sort of clear, but it's for the variable export, not for the variable change. So we know if it's variance, it has to be one of the ones with squared dollars, and it's going to be the 1228 there squared. And I'll verify this. I know which one it is, but it's this one. That's just 1228 squared, the standard deviation squared. And in number 11, the area between x and 1, between Q1 and Q3, is known as the interquartile range, which you might see as IQR in some things. That's the interquartile range. I think I'll